So let us continue with chapter 1, database users. So who are the different users of a database? The book divides the users into two categories, actors on the scene and workers behind the scene. Let's start with the second one first. Who are the workers behind the scene? These are the people who design and develop the DBMS software. So we know that the DBMS is a large software package. It needs to be designed and developed by some people. So let's say we have the Oracle DBMS. It's a well-known DBMS. It's a large software package. So Oracle will hire many software designers and software developers to design and develop the Oracle DBMS. So these are the workers behind the scene. And the actors on the scene are the people who will make use of the DBMS. So once the DBMS has been developed, the DBMS will then be used by the actors on this scene. And there are 4 categories here that the book defines. Let's look at them. Database administrators. Database administrators, DBA in short, DBA, the database admins, they're responsible for maintaining the database. So the DBAs will create user accounts of all the other users in the database, give them their username and password. The DBAs are like the super users of the database. They will coordinate and monitor the use of the database, make sure that everything is running smoothly, efficiently. The software and hardware resources are sufficient for the handling of the users of the database. This is the responsibility of the database administrators. Then we have the database designers. The database designers will define the structure of the database for a particular application. So let's say we're designing the database for storing the data of the students of Bragg University. In this case, the mini world is Bragg University. The database designer will need to interact with the end users who will make use of the database. So the database designers will need to sit with the registrar office, the account department, the faculties and students of Bragg University, understand what are the customer needs, the customer's requirements. And based on the needs of the end users of the customer, the database designers will define the structure and content of the database. And then we have actors on the scene. These are basically the end users. The book defines 4 types of end users, but you can boil them down to 2 categories. Those end users who are technically advanced, so they know SQL, structured query language, so they can write the query in the database, run the query and get the results. Some of the advanced end users are programmers, software engineers and programmers. So they can write the Java program, their PHP program. Inside the Java PHP program, they can write SQL queries, which will connect to the DBMS, execute the query, get the result that they want. But some end users may not be technically advanced, so they may not know SQL, they may not know programming. So for them, there will be a nice graphical interface with menus and buttons. They may need to enter some data in a text box, click some buttons, choose some menu options, and they will get the result that they want. So the DBMS can handle any kind of end user, those who are technically advanced and those who are technically not so advanced. So these are the different database users of a database system. Now, what are some of the advantages of the database approach over file-based? We have already discussed that. There are 2 main ways of storing and manipulating data, file-based approach and database approach. So why are software applications moving away from file-based approach to database approach? Is because there are a number of advantages of database approach over file-based. The first advantage, controlling redundancy in data storage. Now, what does the term redundancy mean? Redundancy basically means duplication of data. Redundancy means storing the same data multiple times without any benefit, without any need. We saw an example in the file-based approach of data redundancy, where the same data like student ID, name, phone number, the basic information of the student was being repeated in multiple data files, because each department, register office, accounts, CSC department, they all need to store information about the ID, name, etc. So the same information is being repeated in multiple files. So this was an example of redundancy in the file-based approach. However, in the database approach, we do not have the problem of redundancy. Why is that? Because in the database approach, we have one centralized database which will store all the data of the students in the database in one place. So information like ID, name, etc. will not be repeated, but only stored once in the centralized database. And all the different departments of the university will share the same database and access the same database. So the data will be shared by multiple users of the different departments. So there is no redundancy in the database approach. Using DBMS, we can control access to data, who has access, who does not, through username and password. We can control access to the data. Some databases are object oriented. So you can store objects in the database and retrieve objects from the database. So let's say you have a student object in your Java program. You can say database.saveStudent. All the data in the student object will then be saved in the DBMS. When you want to retrieve the data from the database, you can say database.getStudent, and it will create a student object for you with all the data of the student inside the student object. So it makes it easier for the programmer to store and retrieve data from an object-oriented DBMS. In databases, query processing is much more efficient than files. This is because the databases use certain storage structures such as indexes, which makes it more efficient for processing the queries in the database. So if you have a file which is 10 megabytes large and you have a database that is of the same size, 10 megabytes, the query processing in the database will be faster than in a corresponding file of the same size. So database queries run faster than files. Databases provide a simple command for backup and recovery of your data. So you can use a simple command to create a backup file of all the data in your database. It will create a compressed file, like a zip file, of all the data in your database. And if for some reason your database system crashes or your hardware crashes, you can use your backup file to recover your data in your database. DBMS provides different interfaces to different types of users. So those who know SQL, for example, they will be given an interface. They will write the SQL query, connect to the database, get the result they want. Those who are application programmers, such as Java, PHP programmers, they can write the Java, PHP program. Inside the programs, they will have the SQL queries. They can connect to the DBMS and execute the query to get the data that they want. And those who are not so technically advanced, they don't know SQL, they don't know programming. For them, there will be nice graphical interface with menus and buttons and text boxes. They can simply click on some buttons, pick some menu options, and get the data that they want. So DBMS can support different types of users. And depending on the technical knowledge of the user, there will be a different interface to interact with the different users of the database. A database can represent complex relationships among data. We have briefly mentioned entities and relationships. In chapters 3 and 4, we will discuss this in much more detail. A database can be used to enforce constraints. Now, what is a constraint? Any condition of the database is a constraint. So, an example could be every student ID must be unique. No two students can have the same ID. So this is an example of an integrity constraint of the database. And we can enforce these constraints on the database, meaning the DBMS will ensure that every student data that is entered in the database, the student ID must be unique for every student data in the database. Active rules are certain advanced features of a DBMS. So, for example, you can create a rule in the DBMS. Let's say you're designing a database for a library, BrightView library, and you can create a rule such as when the due date of the book is within 48 hours, then send a reminder, SMS, and email to the user of the library that the book is due in 2 days. So this is an example of active rules, triggers that can be written within the DBMS. If time permits in the lab, you will see some examples of active rules using triggers. Some additional implications of the database approach: enforcing standards. So since all the data is stored in one centralized database, the DBA, the database administrator, can enforce a standard for all the departments that, okay, we will have this particular data format and this particular naming convention for all the data in the database. So the accessing the data in the database becomes uniform for all the departments. The database approach reduces the application development time as opposed to file-based approach, and one reason for that is we talked about program data independence in the database approach. The data structure, the data format may change, but the application program, the way to access the data in the database remains pretty much the same. So this gives greater flexibility to the database designers and application programmers. Therefore, database approach reduces the application development time. Usually, it is faster to develop application using a database approach than a file-based approach. Some applications require real-time current data to work correctly. So, for example, the USIS advising software during advising time, pre-advising time. Whenever a student registers for a particular section of a course, the available seats must be immediately reduced by one when someone registers for that section of the course. And this updated seat availability number needs to be made available to all the students and faculties who are trying to access the same section of the course at the same time. So this needs to be done at real time, immediately, because if this does not happen, then many students may be able to register for the section even though there may not be any seats available. Other examples are any kind of ticket booking system, bus ticket, airline ticket, etc. So let's say there are 300 people who are trying to book a bus ticket for a particular bus from, let's say, Dhaka to Chittagong, but there are only 60 seats available. So only 60 people must be allowed to get their tickets. The other people are prevented from getting their tickets. So this needs to be handled by the DBMS, and it needs real-time information for this. Such applications must use the database approach because the file-based approach is too slow. They cannot handle current real-time information. Only a database approach can handle real-time current information. And lastly, economy of scale. If we have a huge amount of data, then a file-based approach is too slow, too inefficient to handle huge amount of data. We must use the database approach for handling large amount of data in our system. There are certain cases, however, when a DBMS may not be used. If your application is extremely small and well defined, and there is only one user who will be using the data at a particular time, then a DBMS is not necessary because investing in a database and database system, it requires money and time and effort. If your organization is very simple and only one person is using the system at a particular time, then no need to use a DBMS. You can use the file like Excel file to store your data. That will be sufficient. Another case when a DBMS may not be used is if the data is extremely large, extremely complex, that the database cannot handle. So, for example, NASA, which sends their spacecrafts to outer space, the data coming in from NASA is so large and so complex that perhaps a DBMS cannot handle it in an efficient way, in a proper way. In that case, DBMS may not be suitable for such an application. NASA engineers will then need to write their own software to handle their data. No DBMS, no standard DBMS can handle their data efficiently or properly. So these are the two cases where a DBMS may not be necessary if your application is extremely simple or if your application is extremely complex. But in general, over 95% plus of all the software systems out there will make use of some kind of a DBMS to store and manipulate the data. And with this, we conclude chapter 1 of our textbook.